All right, so you asked for it. A deep dive into one of the most impactful works in science ever, Newton's Principia. Bit of a challenge, even for us.
Yeah, but...
We promise to make it interesting, even fun.
And surprisingly fun, too, because the Principia, it's not just equations and dry textbook stuff. It's like Newton's grand plan for the universe. It's the base for, what, centuries of physics, engineering, all that came after.
Okay, so we're talking the book that says WHY planets stay in orbit, HLW gravity really works. It even set up the ideas for, like, rockets launching into space, right?
And Newton did this by being incredibly careful about the core ideas, like take quantity of motion. Today we just say momentum, right? But the way he words it, quantity of motion, it makes you think about the mass, the velocity, how they work together. Just saying momentum wouldn't have that same effect back then.
So he wasn't just watching the universe, he was making the words to explain it.
Exactly.
Which leads us to centripetal force. Now, most people get this as the force pulling inwards, stopping something spinning from just flying off, right?
Yeah, like imagine a ball on a string. The string's the centripetal force, keeps it going in a circle. But Newton, he took that simple idea and blew it up to the size of the solar system. Planets, orbits, it's all centripetal force.
So not just a ball on a string, but what's holding the whole solar system together. His definitions at the start of Principia, they're not just details, they're the whole foundation for a new way to see the universe.
And it went beyond just like physical forces too. He even questions time and space, saying what we experience every day might not be the whole truth.
Wait, even time? How can our idea of time be wrong?
See, that's Newton for you. He's saying there's an absolute time, an absolute space. They exist on their own, whether we're here or not. This shook up science back then, which was all about what you observed, mixed with philosophy, even religion sometimes.
It's like he's saying, yeah, we feel time passing, but there's a deeper truth to it. Bigger than just a new physics law, it's a whole new mindset. Did people accept this right away?
Not really. Imagine you're a scholar, used to centuries of tradition, and bam, these wild ideas. Some were skeptical, even fought back. But this new way of talking, with math at its core, logic, it lets scientists talk clearer, work together better. That changed how discoveries were made, how they shared them.
So these big ideas, they actually changed how science was done. Amazing. But Newton didn't stop at redefining time, did he?
Oh, no. He then uses all this to come up with his famous 3 laws of motion. And everyone remembers that what goes up must come down.
Bit.
But there's so much more to it. Those laws are like the basis for all physics, from how things move here on Earth to planets and stars way out there.
Exactly. And how he got to those laws is as impressive as the laws themselves. He didn't just think about it. He actually went and tested his ideas.
So like he went beyond just this is how it should work and actually checked if it did.
Yeah. A great example is how he shows his third law, the equal and opposite reaction one. He describes this experiment with pendulums colliding into each other.
Okay.
But he's super detailed, right? Like, not just what he sees, but how he might be measuring things a bit off, the whole scientific method thing. He set the standard. So proving his ideas, not just stating them. That's a big deal for science, even now. But then he connects this to, like, planets and stars. That's wild.
That's where it gets really amazing. He goes from these laws of motion to the whole universe, basically.
This is where gravity comes in, right? We all hear about the apple and all that, but how does falling fruit turn into explaining how planets move?
It's all about his law of universal gravitation. See, Newton proved with math that planets, they move in those elliptical orbits because of force. And that force is weaker the further apart things are. That's gravity.
So the apple, the planets, same force, different scales. That's got to be one of the biggest aha moments in science, connecting those.
For sure. And he didn't just describe gravity, he made it measurable. Gave us the math to use it for stuff here and stuff in space.
And speaking of here, Newton also tackled something we see every day, but nobody ever thinks about tides. I never got how those worked until now.
It shows how something way out there, like the moon, affects us directly. Remember, gravity depends on mass, but also distance. The moon's smaller than the sun, obviously, but it's way closer.
So even a small pull can have a big effect up close.
Exactly. The moon's gravity tugs on our oceans. That's what makes those bulges of water, the high tides.
No way. The moon's pulling the water towards it. That's what we're seeing.
Yeah, and because the Earth's spinning while this is happening, we get 2 high tides each day, more or less lined up with where the moon is. It's like this cosmic dance Newton revealed.
So cool. He's showing us this whole system, everything connected, makes you appreciate how complex it all is. But he didn't just stop at planets, did he? He even explained comets, and those seem way more random.
Right. Back then, comets were like, Spooky, unpredictable, nobody knew what they were really.
Like the wild card of space.
Right, some even thought they were just like vapor or something, not solid. But Newton, he looked at them with his laws in mind.
Okay, so how do you apply these groundbreaking ideas to something as unpredictable as a comet?
By like really digging into how they moved. Newton showed that comets, they follow the same rules as everything else, gravity, orbits, the whole deal. That meant they weren't just vapor, but actual stuff held in place by the sun.
So he explained them, but also made them part of the system, not just some weird exception.
Yeah, exactly. Even those seemingly chaotic comets had a place in Newton's universe. But get this, his desire to measure and understand, it didn't end with big stuff like planets or comets.
There's more. What else is there?
He calculated the density of the Earth itself.
Wait, what? How do you even start to figure that out? It's not like he could just weigh the Earth.
True, but he had something just as good.
Ah,
His understanding of gravity. He knew the Earth's size and had a decent idea of how strong gravity is here on the surface.
and from that, he figured out the mass of the whole planet.
Pretty much. By combining his knowledge of gravity with really careful observations and math, he learned something amazing.
So he, like, weighed the Earth without needing a giant scale.
Exactly. And his calculations showed that the Earth is actually denser in the middle, which is what we know now about the Earth's core, right? But he figured that out way back then, just from understanding how gravity works.
It's just wild that he figured all that out.
Yeah.
About our planet, the universe, with what they had back then.
Yeah.
Shows how strong those ideas were.
And they still are. Like, think about it. Centuries later, we still use Newton's laws for tons of stuff. Sure, we got quantum mechanics for the tiny stuff and Einstein's relativity for the really big or fast things, but for everything in between, Newton's still the man.
It's like, he gave us the map, and yeah, we've added to it, explored more, but those basic routes, they still get us places.
Exactly. And maybe that's the coolest thing about diving into Principia. It's not just history. It's still alive, you know, affecting science today, technology, everything.
From rockets to, heck, even us talking like this, recording this, it all goes back to what Newton wrote down.
And it reminds us that wanting to know stuff, figuring out how the universe works, it never really ends. We're standing on the shoulders of giants, like Newton said, and now it's our turn to keep asking questions, exploring, seeing how far we can push our understanding.
So as we wrap up this deep dive into Principia, here's something to think about. What's the big discovery happening right now that's going to change everything? Like, not just answer stuff, but make us ask whole new questions, the way Newton did.